Everyone, and welcome to the Measure Index Performance in Azure Cosmos-db SQL API learning module. We're here, Michelle Gutzait and Hasan Savran. Hi, Hasan.
Hi, Michelle. How are you doing?
Oh, I'm great. Thank you. So let me introduce myself first. My name is Michelle Gutzait. I'm a senior solution architect, and I'm also a Microsoft Data Platform MVP. I work at EPAM. I have 30 years plus experience in IT and over 20 years experience with SQL Server and Azure. And I'm very excited to be here. How about you, Hasan?
Yeah, thank you, Michelle. It's great to be back here. My name is Hasan Savran. I'm a data platform MVP, and I'm from Cleveland, Ohio. I am my own company, Savran Web Consulting, focusing on the azure-cosmos-db. Also, I have a full-time job. I'm a business intelligence manager at Progressive Insurance. And I have some good experience with Cosmos DB, and I'm happy to share that.
Wow, that's amazing. So you have the QR code here, and you can follow along the learning module. So we're just going to present this module for you. We're going to give you some examples, real life examples. They are going to be very close to the labs that you're going to do. So let us get started.
Excited.
Very excited. So why is it important to learn, to have interactive learning? Hasan, what do you think?
So this module here is pretty important for anybody really, if you're a developer or DBA, because you are going to have some issues when you go to production, just like in other databases, and it's we are going to try to help you whenever a query is costing a lot of request units, or if you try to make things a little bit faster. This module is going to be for you. And it's going to be really interactive. It's kind of amazing Microsoft actually made this available. I was amazed when I was even writing the username and password. You just click the buttons and it just fills it for you. So it's pretty amazing what they have done. And this is just part of, like many other modules. And if you have other questions about the Cosmos DB, check out this, website here, and you will find all kind of topics.
Yes, so this is only one part of the entire module about Cosmos DB development. So please feel free, if you haven't done so, you need some background for this module. So especially around the queries, around the indexes, and how Cosmos DB creates the indexes and other stuff around indexes. And we're going to talk about performance of the indexes.
And Michelle, also, I just want to add, I just actually think about this. There are some other tools you can actually use, like we have, for example, Cosmos DB emulator, right? You can actually download it, and you don't really need to go to Portal or any kind of, modules here. You can actually do it locally with the emulator. An emulator is available in a Docker container. It can be Linux, it can be Windows. You can run it like that. And I like it that the last version of Visual Studio 2022, it comes up actually with the Visual Studio. You can add that as a dependency, which is great. And also, you have the free tier from the Azure Cosmos DB, which gives you 1,000 request units per free. And also, it gives you 25 gig storage for free. So you can really use those other, items or the other things that I just counted to actually make this for free.
That's amazing. And I think you're going to show us one of those tools, right, sir?
Yeah,
Son?
I will.
Okay. So very exciting. Okay. So why is it important to get certified? Because when you look at your resume, when people are looking at your resume, and you're looking, even though you already work with Cosmos DB, I think that when when the recruiters they see that you're certified, it brings your resume up on top of the list, right? What do you think, Hasan?
Yeah, I mean, I'm a manager, and whenever people, I see the resumes, and if I see certification out there, it just kind of shows you that you are serious about learning, and really that's always a positive for you. And I have a bunch of certifications myself, and every time, really doesn't matter what the topic is about. Every time you start to kind of look at and study, you learn something new from it for sure. So it's not just like that piece of paper, but at the end when you are studying for it, you learn new things. So it's great that actually Azure Cosmos DB has one right now.
Yeah, and these modules are covering a lot of the Cosmos DB SQL API. So this is really good, experience with all the labs that we can do. So let's get certified.
I agree.
So what are the learning objectives of this module? So first, okay, go ahead.
So the first one is going to be the indexing metrics, and we are going to look at the indexing policies here, and we are going to try to look at the indexing metrics and maybe try to go back to indexing policy and maybe change, include or exclude items depending on the the data we are going to get from the indexing metrics. Or what else you can do is probably the request units. You can look at the request unit numbers, how much actually that cost you, and if the number is high, then that means there might be some opportunities out there for you. So those, we can go back and tune the indexing policies depending on those.
And Hasan, why would we need to change policies? What are the cases that you think we can change the policies for?
So usually, like in any databases, let's, for example, talk about SQL Server, right? Why do you create indexes? Because you want to try to make things faster. You might have a query out there. It might take too much time, and you create an index, and it starts to take, less time. So it's really the Cosmos DB has the same thing, and you might have, maybe an item out there you are looking for that might not be indexed. So you can include that, so it will be, cost you much less. Or, in Cosmos DB, you can actually, if you are not using the index, you can actually exclude the index, so you can save from the storage. So that might be that case.
Mm-hmm. So you know that I just wanted to add that in Cosmos DB, by default, everything is indexed. So that means more space. And that means also that if you have write-heavy loads, it's going to affect performance. So maybe if you want to do, let's say, a very heavy load of data, you may want to change the policy so that nothing is being indexed until you're done. And we're going to cover this in this module, right? So let's continue.
Right.
So in this in the live chat, you can say hi, tell us where you're from, what interests you, and feel free to ask questions. If we have time, we're going to answer the questions, and also we have moderators that can answer the questions for us. So let's start. Are we ready?
Good to go.
So,
all right.
Go ahead.
So, as an introduction, well, I guess the first thing you kind of need to probably wondering is, okay, why do you want to change it to your indexing policy? Which I tried to explain a little bit earlier, but you might have some queries out there costing you a lot of, well, literally money because it's the request unit. So you might want to actually go and try to find those queries and try to kind of tune up your indexing policy. So we are going to actually have some demos for that. But usually the first question I get with that is, okay, how am I even going to know that I have some queries out there that may need some attention? So really the best thing for that is the Diagnostics log. You can actually look at all the queries out there running. So you can actually filter that. You can filter by the request units, how much they cost, or you can look for the latency. So that will give you, idea how your queries are doing, and you can pick one from there, and then we can look at the indexing metrics, and we can run that, and it will give you some kind of maybe suggestions, and depending on that, you can go back and change your indexing policy. But I guess let's try to refresh a little bit. Michelle, how about changing the indexing policy? How do you even change that. Can you tell us some more?
Yes, so for each one of the items, and we're going to see this in the demo if we have time, you can basically modify the index policy for that specific item, right? So basically, if you don't want anything indexed, like we said before, if you do a big load of data, you don't want your performance to be slower, you don't want to incur more storage, so you're just going to change the policy not to have any indexes, and you upload the data, and then you change back the policy to either have all the indexes back in place, so everything by default being indexed, or specific indexes for specific queries if you know that you have like specific queries in your database. And also, you are able to measure the cost for a specific query or operation, and we're going to see some demos how you can do that even by adding a portion to the code if you're debugging your your operations. I would recommend to refresh your memory before if you haven't done so, and look at additional information about indexes in Cosmos DB. So the link is here, and also to this specific module. So let's do just a little recap about what we said. So this is an example of how you can do this through the Azure portal. You can change the index policy. So this is a JSON, and as you can see, what's important for us is that you can change the included paths and the excluded paths from the index. So whatever, so let's say that you can say, okay, I would like to index everything excluding this specific path. So it's going to make sure that the excluded paths are going to be excluded from that particular path that is included.
Yeah, so Michelle, if I want to add a couple of things here. So really, if you compare that, many people have experience with the SQL Server. So in SQL Server, usually you create a table, and well, hopefully you have a primary key on it, and usually that's it, right? So after that, you need to start to include other indexes depending on your filters, and you can make the things faster like that. So I guess that concept fits in the included paths here. So those are the paths that you want to get indexed.
Yes.
And excluded paths, those are the ones that you really don't need them. For example, you might have a column out there, I don't know, let's say maybe description, which might be a huge text, and you might not be using that in your where filter, and you can just exclude that. And why do you want to exclude that? Well, you have a data file and you have an index file in Cosmos DB, and index file size depends, how many properties you actually index. So if you are indexing everything, then that means the index file might potentially be larger than data file. The problem with that is, well, you pay for storage too. So by excluding all the properties, you might actually save money, depending how much actually data you have in your database.
Great comments. And as opposed to in SQL Server, you can include a where clause with any column that you wish. And if it doesn't have an index, you will just not have the greatest performance potentially if the table is big. But in Cosmos DB, if a column is excluded from the index, or if you exclude everything. So if it's excluded from an index, or it doesn't have, or it's not part of an index, you will get an error. And in the lab of this module, there is an example what happens when you include columns that are not indexed. So you're going to, the operation is going to fail, right? So only if you're very sure, for your example of description column is perfect, because potentially people are not going to do a where clause on this column.
Correct. And this is what you see here is just the the default indexing policy,
Mm-hmm.
and it works great, especially for developers, so they don't need to worry about indexes because everything is indexed, right? So this is great when you are actually starting from the development. But when you push this in production, you might want to kind of come back here and revisit this, and by all the other stuff we are going to actually cover here with the indexing metrics, request units, and other stuff. Those going to be kind of help you to figure out what to exclude. And also, there's a whole different indexes, composite indexes, which they are not even included here in the default one, default indexing policy. Indexing metrics actually can suggest you those two, which they can save you a lot of request units,
And,
and it can make things faster.
and we're going to see that in the example, right?
Correct.
Awesome. So let's talk about enabling the index matrices. So you sometimes you want to tweak the default policy as we discussed before, because the indexes are going to improve your read operation. So you, Hasan, you talked about composite indexes. So when you know your queries and you know that you need a composite index to make your read operations better, you will add this index. But you need to remember that indexes are always heavy, no matter what the database is, for the write operation, right? If you want to insert data or update data, you have you incur more storage and you do more writes. So your indexes are going to be larger if you, for example, you insert data, right? So anyways, the more indexes you have, the more costs you have. So this is why we would like to sometimes change the index policies and either reduce the number of indexes or add indexes that we really need. Anything else that I didn't say, Hasan?
No, I think you explained it very well. If I give maybe examples, like for example, heavy writes, if you have an IoT application, right? So your IoT application might be just pushing data. It might be small, maybe 2-3 kilobytes, but maybe it's, throwing data to Cosmos DB every second or every 10 seconds, right? So that becomes a big data pretty quickly. And if you are indexing everything, I'm not sure how big your, the document is, but you might not even need to worry about the analyzing data, because for IoT there's different kind of ways to kind of look at that data, and you might not even need to look at the Cosmos DB and kind of try to write a select statement for it. So if that is the case, maybe even disabling the indexes might be a good thing for you, because storage wise the index file can get pretty large. So that might be an example for heavy write applications, or maybe this is the first time you are actually pushing data to the production, and maybe you are moving data from, I don't know, from SQL Server to Cosmos DB, and that's a bulk load. I don't know, let's say it's a 1 terabyte data. So you might want to just cancel all the indexing first, move the data to production, then enable the indexes, and actually maybe you can change the indexing policy then. Because if you really think about it, if you are going to make the indexing policy available when you are pushing that large of data, well, it's going to make things slower, because you need to write the data to data file and the index file. And probably after a while, when you are done, you are going to go back and change your indexing policy anyway. So you are really doing indexing twice, if you really think about it. So I guess those are the, I guess, 2 examples I can really think of for the heavy write applications.
Yeah, great examples. And just we shouldn't forget that Cosmos is a distributed database, right? So if you do have many copies, probably the performance is not going to be as affected as, for example, if you have just one SQL Server instance, but still it can be affected, right? And for sure the prices, because you have more storage and more operations.
That's correct. So if you have large operations and large storage size, you're going to have more than one physical partition. And if you have more than one physical partition, if you change your indexing policy, then that means you're going to change that in each physical partition, then which can actually take a longer time.
Correct.
Yeah.
Thank you. So here's just a code example with C# on without the indexing, without looking at the indexing. So this is your code, and you're doing a select star from a products document, and then you just you query into line by line, and you write something in, you write the product ID, the product name, and the product price. So this is example without indexing metrics, because by default it will not show you. But now we're going to see an example where you can use the populate index metrics and enable it so that you can actually troubleshoot query performance by looking at at the operation and looking at the index metrics. So I think, Hasan, we're going to move back to your environment and see an
Yeah.
example.
So I can show you actually some examples here. So I'm just going to look at my monitor, so don't think that I'm ignoring you. I'm just going to need to change my, I guess, view here. So let's say we have this select statement, and in your module, that's a different select statement. So really, it doesn't matter what you are running. So this is my comment, and I want to actually run this in a query. So I have a bunch of stuff here. So I'm going to let's actually do this from scratch. How about that? Let's say we are going to run, let's make this simple and say run query. And we are going to pass a query. So this will run all the queries. Now, well, look at that. Actually, I didn't have to write the query function because I don't know if you ever heard about the GitHub Copilot, but now GitHub Copilot is actually telling me this function should look like that, which is amazing if you really look at it. All I did is I just give a name to the function, and AI actually figured it out that I have Cosmos-db. These are, actually, let me accept this and let's see what this looks like. It already knows my database. It already knows my container. I really didn't have to write anything. I just write the run query here, which is great. So let's be sure that actually this is going to do whatever we are trying to do. So as you can see, I'm getting the query, and this is the get item query. So this is the function actually we want to change, and we are going to add the populate index matrix here. So, well, let me be sure everything else is fine here. So it's going to display the number of posts. Okay, so now we are going to actually add here. It's going to be under the request options. So request options is going to be here. 1 minute. Let me make this a little bit more clear here. Request options. Well, it tells me, so I will take this as it is too, and I don't want to change the consensus level. I don't want to change the gateway. I just get rid of those, and I'm going to say populate index metrics equals true. So by just doing that, what I'm really doing right now is this function is going to run a query. Query is going to come in. Those are the connection string. Everything is fine. So in here, I am just saying the populate index metrics. And from here, I'm going to go and get the data. And the data is going to be here. It's going to change everything to the object, which is the Stack Overflow post. So let's try to actually display this indexing metrics. If we are going to do it this way, well, if we are going to make a loop, if I'm going to try to put it here, it's going to display it multiple times. So I'm going to take this out of here, just so I don't have to display it multiple times. Just define this here and take my object name and put it here. Now I can go here and say current result set indexing metrics. As you can see, and we want to display that. So let's say console write line and display our indexing metrics. Now, let's look at this one more time. So we just defined the populate indexing metrics, and we want to display right line, and let's actually call our new function here, run query our CMD. Cross the fingers. It's always risky to do this, but it's fun. So let's see what's going to happen here. So we are going to actually run this select statement, and I'm looking for the owner user ID 1 and owner ID user ID 1, all the posts from that user, and I want to see that all the if there's any view count larger than 20, I'm going to actually display it here. So that's the Stack Overflow's data set. I put it in my Cosmos-db, so that's what I'm actually querying here. So let's see here. It might be a little bit slower since I'm kind of sharing all kind of information here, video and audio. All right, so as you can see, we see the index utilization information. Since we made that true, actually the output comes up as we have to utilize single indexes. You can see that owner user ID, we are actually using it. We have the view count. As you can see, we are using that. So that really means that do not touch them because Cosmos-db is actually using them. If you remove them, probably requestion is going to go much higher. But really interesting ones here that actually you see we have the potential composite indexes and potential single indexes, which means that, which we have one here right now, Cosmos-db believes that if you actually add that to your indexing policy, it might use it. It might. It doesn't mean that, it's going to give you great performance because whenever actually it's creating this, it really doesn't check your data. And you don't want to change this in production directly. You want to go and do this in tests and be sure that actually it's going to give you some kind of change, a big change, so you can go back in production. So don't try to, I guess, try them in production. Just try them in test environment first. So this was how actually you do the indexing metrics enable. So I'm going to actually show you. I have two more demos for you. If you are a DBA or if you are somebody that you don't know C#, so you might be almost, lost right now. So just, I guess, stay out there for, I'm going to actually show you another way to do this. The next one, actually, I'm going to show you. So this was the first way. If you have .NET SDK or Java SDK, this should work for you. If you don't have those, for example, I have some with the JavaScript SDK, the indexing metrics is not there yet. So what you can do in that case is actually you can use the REST API of Cosmos-db. So I'm not going to go in very details. If you are using it, probably that's going to make sense already. So I'm going to use the Postman to actually show you. So all you have to do is in the headers, you really need to pass XMS Cosmos populate index metrics. That is the header that you need to include in your request headers, HTTP headers, and you are just saying this is true. Then the body is going to usually have your select statement, which is the same select statement here. So if I'm going to actually send this to Cosmos-db, when the result comes back, you are going to actually see in the headers, you will see, let me, XMS Cosmos index utilization. The tricky part is it comes up in base 64 format. So you are not going to be able to kind of read this immediately. So in your code, you might need to convert this to base 64. I believe I have, yeah, let's paste that here and let's see what this thing looks like. If you decode that, as you can see, you are going to see the same, the indexing metrics. So you can do it this way in the REST API if you cannot use, if you are not using the .NET SDK or the Java SDK. That was the second way. Your question, Michelle?
No, I'm
right.
waiting for you to show the the other two options.
Okay, so the last option is most of the time, I talk about the Cosmos DB a lot, and whenever I have people who doesn't know .NET or who are not developers but who wants to learn about the Cosmos DB, unfortunately they got lost when we show codes like that. So that's one of the main reasons really I create this VS Code extension, and you can actually see it everything here without knowing any kind of .NET or Java or JavaScript, whatever. So what I'm gonna actually do here is you can actually get that for free. It's totally free. You can look at the VS Code extensions here and look for the Cosmos DB SQL Studio, and you can install it from there. After it installs, to actually connect, it's going to ask you the connection string. Then you are going to be able to see all your databases. And after I pick my database, it's going to show you all the containers under that. So I'm going to actually go with the post 0 here. So I'm going to run, for example, let's try to run the same query here. Select all from C, where C owner user ID is 1. And let's just run that. So execute it. And you are going to see the results under here. So it looks like we have 68 results. And to see the indexing metrics, actually, you need to kind of enable that here. So it's under the options. You want to be sure that that is checked. And if you check that, then really all that code that I just showed you, application is going to run for you. And it's going to actually display that user-friendly way in here. So as you can see here, it says, okay, in your query, this is utilize indexes. You can see all the owner user IDs here. And if you are going to actually add and say that I think it was view count larger than 20. If you execute it again, then you will see that, potential indexes here too. So that's, I guess, the third way to do this for free. And we will kind of look into that a little bit more later. But those are, I guess, the 3 ways I can really think of to enable indexing metrics. But the one that you have actually in module is going to be this way, which we just add query request options, populate index metrics is true.
Okay. So I will take over. So thank you very much, Hasan. Wow, that was amazing. So we have a lot of options. The other option that you guys have is through the notebooks of the Azure portal, right? And this is the lab is showing you how to do that there. So if you just go through the lab, it's very straightforward. You just go and follow the instructions, and you will see also those index metrics when you create queries, and you can see everything and you can compare. So the lab is really straightforward and allows you to understand how to view the performance of different indexes. Do you have anything else to say, Hasan?
Well, you can tell I'm thinking. The other thing I was just going to add, I was actually thinking when I was writing this is, don't forget that Cosmos DB is a distributed database. So, you might have more than one physical partition. And if you have more than one physical partition, you have database engine in each physical partition. So I guess that's how the REST API is working, because in the REST API you cannot do the cross-partition calls. So I guess you kind of need to watch for that. You have to define if you have more than one physical partition, you have to define the one partition to actually be able to get the indexing metrics.
Okay. Would you like to show that? We can do it later when we're talking.
We can do it later. I think I have some other demos that I can show you.
Exactly. So let's continue. Can you see my screen? Can you see the PowerPoint? Okay, awesome. So let's talk about analyzing the indexing metrics results. So these are the default index metrics. Like we said before, we showed an example with the JSON. So the defaults are using the consistent indexing mode and automatically indexes everything. It includes all the paths, and it's always exclude the e tag properties of the document, and it does not contain any composite key indexes. So this is like a summary of what we have discussed. If you need to modify, this is the default. If you need to modify the default, then you have to do so. And so we're going to see an example. So Hasan started showing us an example on how to do how to look at sample queries and understand how you can view some information about the metrics. You do have additional metrics. So I'm not sure, Hasan, we showed everything, right?
Correct.
Related to
We
this?
show all the indexing metrics. Yeah.
Okay. So let's move on to see how we can measure the query cost. So we can see the index measurement, and now we're going to talk about the query cost. So another thing that we have in .NET is the query request option class that can help us review the cost of the queries in RUs, which is the request unit per second in the Cosmos DB. And so what we can do is we can just look at each one of the iteration in a loop and print the RUs, as well as review the aggregate of the RUs per the entire piece of like the entire block of code. And this has to be done outside of the while loop. So basically, when you the max item count allows us to retrieve. So basically, if we do select star, it will retrieve everything, but it will retrieve 20, for example, 25 rows in at a time, right? So Hasan, would you like to talk about that?
Sure. Actually, you know what? I think let me start to share my screen. So when you actually see this on screen, it might make more sense. So I'm going to get a couple of queries in my screen here. So in your module, probably you're going to have different select statements. All you have to do is really just change the select statement, and the indexing metrics is going to be different. So I'm going to try to use this one, since this is more visual and I don't have to worry about the console write line and other stuff. So I guess everybody can see this better. So really, this is the query that I used as a basic, but what's going to actually happen when that actually gets more complex? So let's, for example, try to write different ones. So let me actually get one from here and try to see, I guess, some different request units and different indexing metrics before I start to look at the max item count.
And right now you have the default policy, right?
That's correct. So let me actually take this out. So in here, I'm getting top 10, and I'm looking more like I have a range here rather than equal to. So that's going to be a little bit more higher. And also, I have an order by. So if I run this one, and let's look at our indexing metrics, see we have actually more results now. So indexing metrics actually tells us right now that we have score, we are using it right here. We are using owner user ID. We are using view count. This is kind of weird. This is the first time actually I'm seeing this, because it suggests view count is low and view count is high. I'm not sure why. But if it's in here, just don't touch it. I mean, do not exclude any of those items. If you do that, the request chart you see here is going to go much higher. What you want to focus here is the potential indexes, and it actually suggests us that we might be able to create a composite index for owner user ID or score. If we add that, you might see some difference. It's not guarantee. It's just a tip, really, from Cosmos DB, and you can try it in a test environment. And if it makes a big change, a big difference, please go and change in production, so you will pay less request units for that, and hopefully it will be much faster. In the same way, it says owner user ID or view count might have a change, or it says that if you have that Cosmos DB, might actually use it. So as I said before, those are the suggestions. It's your responsibility to figure out if they're going to make any kind of difference on your queries. You might actually do this for different queries. So let's say, you figure out that, okay, owner, user ID, and score made a big difference in test. I am expecting that production is going to do the same. My suggestion is first, keep that in sight and look at the other queries too. So let's say we have maybe another query that we find from diagnostic logs. And let's say it's a little bit more complex. This one has actually array. If you execute this one, now you actually see that it's using the tags array here, and you can see the composite index for array. So let's say in this one, tags and score made a big difference, and you're very happy. Your manager is going to be very happy. So you're going to push this in production. I guess the reason I say that, keep the other one inside, I really suggest you to kind of make all those index changes in the same time. Do not try to kind of, create this one, then create that one. Because as I say before, it's a distributed database, and sometimes depending on how much data you have and how much threshold request units you have, it might take sometimes days to actually complete reindexing. So try to, make all those index changes in the same time. Now, okay, sorry, I'm going to actually look at the max item count right now. So the max item count is, so as you explained, Michelle, so we have a request and we have a response from the Cosmos DB. So when you make a request, there are actually 3 numbers that you should know. The first one is Cosmos DB promises you that it will return something in 5 seconds. Second one, the page size, which is going to come back as a response, is a limit, 4 megabytes. So it cannot be more than 4 megabytes. So the third one is the max item count, which Michelle was explaining. You have control, you have actually override that. So by default, it's 100. So if you actually look at here, we have options, max item count, default is 100. In the SDK, you can make that -1, and that means it will select automatically for you. So what you are really saying here is you are going to visit Cosmos DB for every 100 items for your query. So if your query is returning 150 rows or 150 documents, that means you are going to call Cosmos DB twice, because you are saying that one request or the one response cannot have more than 100 documents in it. So if I will demo this one for you, I guess we can try to make this one a little bit different here. Say, where's C? So right now, this report, this gives me 68. And if I'm going to go back here and change my max item number to, I don't know, let's say 25, right? The request charge is going to get higher, because actually you are going to hit the Cosmos DB 3 times to get the 68. That's one of the main reasons you're going to see that request charge is going to change. As you can see, 11.92.
So it changed from 6 to 11, right?
Correct. And I just show you this one, but in the module, I think you do that from the Visual Studio. So really, if you want to overwrite the, this property, you are still going to use the query request options if you are doing this by the SDK. And you are really going to say here, max item count. GitHub Copilot tells me I should put -1. Well, you can write here, whatever actually makes sense. So you can keep it -1, or you can keep it 25 here. Then if you want to, demo this one. So let's look at our query. I'm going to take this out. Now we are saying we are going to run this query. We are going to look at the owner user ID once posts, and each response is going to have 25 documents in it. And each response, if you have more than 25, it's going to come back with a token called continuation token. If there's a continuation token, this is going to say has more results as true, and that means you're going to go in and get the next set. So let's see if you want to demo that. Michelle, what do you think we should do here?
I think if you want, so we want to know the metrics, the query metrics, and we want to see how it works with 25, how it works with 100, and compare.
So what I'm gonna do here, as you say, I am gonna actually, let's look at how many times we are actually visiting the
Cosmos.
So let's try to count that, I guess, first. So for each time, I'm gonna say I have an index. It is 0, and for each loop, I'm gonna add 1. Let's actually display that in here, and let's say, I don't know, the cosmos-db visit, and we will say, well, plus I. So this should actually show me how many times we visit cosmos-db for this query. Let's run that, right? Let's look at it. So our max item count is 25. So when this runs, we should be able to see that actually we are visiting cosmos-db more than once. And when that happens, you know, since this is a query, and each query minimum costs you 2.5 request units. So as you can see, I am calling 1, 2, 3, 4, 5, 6, 7. Oh, I'm going 8, 9, 10. I call cosmos-db 13 times to actually complete this query. This one is actually looking at different container. That's why, because the one I actually displayed here, I have 2 items which I was going to actually talk about this distributed. So this one actually has only 1 partition. 1 partition, I know where my data is. I go straightly there and get my data. But the one actually you are looking in the .NET has 5 physical partitions. What does that mean, Michelle? Can you tell us?
That it will go each partition 25 to bring 25 or whatever count you put there. So it will go each partition probably twice or a little bit more.
So
I don't know how much data.
At least it will go once. We know that. Since, as you can see, this post ID is the partition key, and I'm not using the partition key, then that means cosmos-db SDK has absolutely no idea where the data is. So it has to actually go and run this query in every partition at least once. And some of them actually has more than 25 records. Then that means I have to go back and, you know, get that data until it finishes. So that's why I ended up with 13 times here to actually get the data. You don't really see that happening in the backend, but that's really when you actually put that all that debug things you will see. So
I have a question.
Sure.
When are you going to play with this number? What are the use cases to play with this max item count number?
So as by default, that was 100, right? So we already changed it to 25, which actually demo us that we start to visit cosmos-db more. So if I actually close this one and put this one, I don't know, 100, back to 100, what do you think is going to happen?
On the partition one, it's still going probably to visit each partition once, but we don't know if more than once.
So we know one thing. I think it says we have 258 documents. So what I'm expecting is it's going to be much less than 13 times.
Correct.
So let's see what's going to happen.
And also, I'm thinking that this strategy is very good if you're using paging, right, in your application. So let's say that you would like the user to get the first 25 results, and in the background you still continuing to get the next ones, right? So for performance from the applications part side, it's going to be much faster. And I think this is one of the reasons why we have that.
That's correct. So, and you can see now, rather than visiting 13 times, we are visiting 5 times. It has to be 5 at least, because we did not pass the partition key. If you pass the partition key, then probably if all the data is in the same physical partition and we are looking 258, then that means that's going to go back to 3, which means the request units is going to be much lower. So that's, I guess, the demo how you kind of control it, the max item count. If I give you another, I guess, example for this one, let's say you have a grid on your page and you display 150, maybe top 150 orders. So by default, you get 100 max item count. So you always get the 150. Maybe for that query, you can actually change the max item count to 150. So you will actually visit Cosmos DB once rather than twice, which will actually save you request units. And you can use a max item count like that.
Thank you very much.
Yeah, no problem.
So I think we can continue with the presentation. We have other exciting stuff to talk about.
Sure.
That was really, really nice presentation. Thank you. So can you see my slides?
Yes.
So let's talk about the measure point operation cost. So you can also use the .NET SDK to measure the cost of an individual operation. But you can also do it with the other options that we saw, including, as you will see in the lab, including through the notebook. So this is an example with from .NET. It's only doing one operation, right? So you connect to your container, and then you add one item. And then what you do is that you look at the request charge per the one operation. Okay, so I don't think we need a demo for this because you already showed us, unless you want to show us the request charge. Maybe it's a good idea. What do you think?
Sure, I can show you the code, I guess, how to get that request charge in .NET.
Just one. Yeah, just one operation.
So as you can see right now, we have everything here working fine. So what we want is the request charge. So right now we are displaying the number of posts. Well, you can add console write line here and say the cost. And well, guess what? GitHub is telling me this is the place. Actually, that is correct. So current result set request charge is gonna tell you the current request unit. But you have to be careful with that, how you actually calculate that, because, you know, as I showed you before, we visited 5 times. This is gonna give you the last one. So what you really wanna do is you wanna take this and kind of sum it up here. So you will actually see what was the total, rather than in here I'm just putting the whatever the last one was. So we are going to do almost the same thing here, sum the request units up here and display the request charge at the end. So that's how you actually look at the request charge. Is under the current result set, which is the read response.
Okay. Awesome. Okay, let's go back to the presentation. Can you see my screen again?
Now I can.
Now you can. Okay, so now after you read the module and everything around it, the module shows you how you do this with .NET SDK, but the exercise is actually showing you the notebook and how to. So it's a lab where you create your own virtual machine. So once you click on the exercise, it spins up a VM for you with Cosmos-DB SQL, and it gives you an example and instructions on how to do the exercise. So it's spinning a VM for you, and the problem is that sometimes you have like a specific amount of time to complete the exercise. It should not take you more than 30, 40 minutes. If you start your exercise and you just go for 10 minutes to make a coffee and you come back, sometimes you will see that the VM is already disconnected and you have to start the exercise from scratch. I think all those models are like that. But that's amazing because you actually create the Cosmos DB database. You could create the resource and you start from scratch, and then you create the container and you create queries and you modify the index policy. So I'm just going to show a little demo of that. So can you see my screen? Are you able to see my screen, Hasan?
Now I can.
Measure index performance. Okay. So this is the module, and you read through the entire module, and then once you get to the exercise, it tells you it's loading the lab, and then you just launch the lab. It takes a few seconds, or a minute, and then you start the lab. So it's actually spinning a VM just for you for free. You don't need to pay for any license or subscription. And then what you will see once it's on is that you have your instructions on the right and your VM on the left. And you just have to follow instructions.
And Michelle, you say this is available for 45 minutes, right?
So it's not quantified. It's really probably based on usage. I was when I was doing this exercise, once I was disconnected after like 45 minutes. Okay. But according to Microsoft, it can vary. You're supposed to have at least 2 hours for this exercise. So this is how it works. So as you can see, we have on the right, we have instructions. So my username is students, but if I want to enter the password, I don't actually have to enter. I just click this T and I am connected. And this is a brand new machine. So like I said, if you got disconnected, you have to start everything from scratch.
So I don't think I can see that. I'm still looking at the SQL API containers index policy page.
Oh, you do?
Yeah.
Okay, so you don't see you see the presentation?
No, just that button, start lab page is still there.
Oh, okay. So let me just, so I don't want to reshare. Let me just try to reshare.
It's amazing what you can do. As I say before, you can really use the module, you can use the Cosmos DB emulator, you can use the free tier. There are options. So if this one doesn't work for you, there's many other options that you can actually create the same thing in your convenience with other options.
Okay. Yes, exactly. So can you see my screen? Can you see networks?
No.
No.
Now something. Yep, I can see now.
Okay. So instead of typing things, you just click on this T and it will do the do this for you.
Nice.
So you have all the instructions. For example, you can just go to the portal here. So where's the portal? Just give me a second. It's supposed to be here as well. The portal here. So you just click here and it writes for you. Can you see that, Hasan?
Yes.
Okay, awesome. So now we're good. So you have to sign up. So to sign in, sorry. So here you go. This
Oh,
is
I
my
love that.
user. Yes,
Mhm.
it's so cool. Like I don't have to do anything. I just watch it run here. And I'm in my portal, my lab portal.
Nice.
If you want, you can start. You can take a tour of Microsoft Azure if you of the portal if you're not sure, or you can just click maybe later, and then you just follow here. It will tell you. So I joined the portal. I do a create resource, and I create a Cosmos DB. If you are already familiar, you can go directly here, create the resource, and so forth. So it's pretty basic. We're going to create the core SQL, Cosmos. You have other options, and you just follow everything that is says here. Okay, so subscription, resource group, and probably better to use the ones that Microsoft already provides so that you avoid problems, unless you
Actually,
would like
Michelle,
to. Mm-hmm.
the one very important one here is anybody who's actually creating this, not in the module, but in the portal, that apply free tier discount. Be sure that you pick apply for that.
Yes. So these are the instructions. Very good point. So you can complete this lab outside of here. Okay. So you can have like in your own browser, and this is where you do it. Okay. So they tell you choose the serverless. So you have very specific instructions here. Okay, I'm going to go back and share my my screen with the presentation.
So after you
And
kind of do that module and you kind of do all the changes with the, you write the select statement, you change the populate metrics, and after that, you might, change the all the other stuff we show you. Then you are going to be ready to change an index policy, right? So you might want to maybe include and or maybe exclude some items if it's a write-heavy application, or you want to maybe take the indexing policy down. You don't care about the indexing policy because maybe this is the first time you are, pushing the bulk load, or you have an IoT application and you really don't care about indexes. So how do we do that, Michelle?
okay, so you want me to go back to the exercise,
Doesn't matter. I
or
mean, I was just asking.
oh, okay. So basically, I wanted to show it, but you go to the item and then settings. I don't know if you have your Azure portal on. If you do, maybe you would like to show this.
Sure, I can do that too.
Okay.
Uh, so let me share my screen here. Right now, you are gonna probably look at my portals. This is not the module, but the module is gonna have exactly the same data. So you are gonna have a different database. I have Stack Overflow here, so I'm gonna pick my container. Then if you look at the scale and settings, then you're gonna actually see the indexing policy here. This is the place that you want to come and actually change maybe included pets or the excluded pets. As you can see, it looks like I excluded post body because that can be a really large chunk of text. I don't want to index that. I don't want to pay for the storage for it. I will never use that in my where clause. So I just came here and actually add the excluded pet here. Or
And and it's important also, sorry, I'm interrupting you, but when you look at the instructions in the lab, if you haven't done that before, remember that in order to see the indexing policies, you have to open the actual item and settings, as you can see. If you can just point your mouse on it, because I had that question once, and
So
under.
I reach from here, scale and settings from the container, but I think
Mm-hmm.
there are many other different ways you can do that.
Yes.
You said
Mm-hmm.
there's settings. Yeah, you can do that from here too, probably. And kind of goes almost the same thing here. So you pick your container, scale settings, then indexing policy.
Mm-hmm.
Potentially, you can do that from the .NET SDK. You can actually change this indexing policy, but I feel like this is much easier because you see everything here and it's much easier to do it from here. If you are going to change the indexing mode to, if you're going to actually turn it off, the indexing mode, just be sure that you know that actually TTL, which is the time to live function, requires indexes. So if you want to use TTL, you cannot turn off your indexes. Just an FYI.
Okay, thank you.
Yeah, no problem.
So we'll go back to my presentation. Let me know when you see it.
Yep, I can see it.
Awesome.
You may want to click on that. I hate that see that, yeah.
Hyde. Yes.
Usually I forget that too, so.
Thank you.
Yeah.
So, so now at the end of the module, you will test your knowledge. So let's do it together. And our host slash moderator can give you the I think you can give us the URL for this, or just take your phone, get the QR code, and
All right.
vote. So let's.
So the
So let's.
question is, you are
Mhm.
creating a SQL query that will run in .NET SDK. Which property of the query request options class should you configure to enable viewing recommendations on single and composite indexes along with the impact of utilized indexes?
And we're not going to
Interesting.
see. Yeah, and we're not going to see your results. It's only for you, so nobody is judging.
That's right.
So
So
look
what do
at
you think,
the.
Michelle?
I'm not going to say until everybody votes.
All right. Well, all right.
So can you see, Hasan, the voting?
I see only
The,
one person right now.
okay, maybe we'll wait a little bit. Maybe people are just reading the question.
Well, so right now the options are max item count, populate index metrics, and enable scan in query. I don't think it's enable scan in query. We haven't even talked about that. So I think I can easily say that that is not C for sure. What do you think?
Yeah, I agree.
How about max item count?
I don't think so, because we already said that this is the number of 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 results that we're going to see in a chunk. So when you're hitting Cosmos DB, so I think it's going to be B. Let's check.
All right.
Yes, it
You are
is.
right. You are right.
Let's continue.
Yeah, it
Next.
looks like everybody actually picked that, so that's great.
Awesome. So you've created a SQL query in .NET SDK and received the response in an object of type feed response. Which property of the feed response should you use to determine how many request units were used per page of results?
probably you will, see similar questions like that if you are gonna, take the Cosmos
Exactly.
DB certification. So it's important, I guess, read the details because, I mean, I took some of those certifications. They can be really tricky. So for that one, what do you think? What is, do you think it's diagnostics?
No, I don't think it's diagnostic. We didn't even talk about that one.
Yeah, we only talk about diagnostics logs, which is gonna give you in Azure portal the all the queries. You can kind of run all kind of queries to figure out all kind of information about your Cosmos DB's queries, how much they request units, latency. You can make it really custom. So it's not the diagnostics for sure. What about index metrics?
Do you have any enough votes in there?
Let me see. Yeah, I think so.
Okay, so let's reveal. Request charge,
That's
because
right.
in the, yeah. So this is
Okay.
an example.
Yeah, so the request charge is the one which is going to give you how much are you your query it costs.
Yes, that was the last example that you showed.
Correct. Looks like
Awesome.
everybody got that too.
Good.
Nice.
So let's summarize what we've seen so far. Are we ready?
Sure.
So we saw how we can review what the indexing what the indexes are doing and how much the query costs with an index, and also recommendations by Cosmos DB, right? So either by a specific query or a specific index. We saw how to change the policy.
Correct. So really I guess the summary for that is, just look at the diagnostic log, figure out which queries are, giving you problems, or you might be even auditing that in your end. So figure out which queries, then turn on the indexing metrics, and let's see what Cosmos DB is suggesting. It's just suggestion. Don't forget that. Just, I guess, test it in your test environment and be sure that actually is gonna make some, changes. So when you are actually done with all the, I guess, checking all the request units, and when you are ready to change your index policy, try to change all of them in the same time because, well, changing index policy can be expensive. When I say expensive, it might take a long time. And when it's changing, don't forget your current indexes will still work until the new one is ready.
Good stuff. And the next one is customize an indexing policy for write-heavy workloads if you need. So really depending on your load, depending if you're doing something temporarily or permanently, you need to decide which indexes you actually need, which indexes you don't need, and do whatever is good for your environment.
Correct. Yeah. I mean, I guess the best example for that is, IoT devices. You have an application in the car. It's just looking at the temperature of the, I don't know, maybe the engine every 1 minute, and it just sends the data. So that's a lot of data because it's going to come from many cars. So do you really need indexes on that? How are you going to analyze it? Because since there's an IoT, there might be other ways to do this. So in a case like that, you just may want to kind of turn off the indexes if you don't need them. Or the other one, I guess you can turn off indexes if you are using Cosmos DB for caching like key value. So probably you might not need the indexes for that either. So there are, some situations that you might need to kind of, I guess, turn off the indexes if you don't need them. So you will save storage. On top of that, since the Cosmos DB doesn't need to keep up with the indexes, things should be much working faster because, well, it doesn't need to go and change the indexes.
Exactly. And another use case that I could see is because if you're using Cosmos DB to enter information in batches, um, and now you can use Cosmos DB with analytics, right? You have a link from Synapse. So you may have like big workloads. You want the data almost real time. So IoT is one of the examples, but you can have other examples where you need data almost in real time, or you have a large amount of data being updated in batches in batches in a short period of time. That's when you need to probably worry a little bit about your indexing.
Correct. Well, I hope everybody learned something new today. And thank you, Michelle. It was great to be back to learn TV. And also, don't forget the names on the, well, let's see here, right here. That's my actually Twitter account. So if you have any questions later, I will be more than happy to answer them. And please, I guess, keep in touch. I'll be more than happy to answer of your questions later.
Yes, same here.
And this module was great. There are many other modules are coming after this, and there were modules before this one too. So just check them out. And this has been going for some time. And all right, the next one is going to be the integrated cache, which is a great topic, especially if you want to cache the data. If you have lookup tables, or if you are running the query a couple of times, or the same query, returning the same data many times, you can actually save a good amount of money with that.
Mm-hmm.
So check it out. I think that's coming up. Next one is June 29th, which is I
next
think
week.
next week.
Next week.
So yeah, that is great. Don't miss
Next
that.
week, same time.
Yep.
And of course, get certified as much as you can. This one is pretty neat to study. It's not very long, and you do have the live TV here to help you with maybe to study, and also some a little bit more advanced topics and demos.
That's it.
And this is it. Thank you very much.
Yep. Thank you everyone for joining us today, and hopefully we will see each other maybe in person events one day.
Thank you.
Yep. Thank you. Thank you, Michelle.
Bye.
Bye.